Hi, this is Lab 1. I'll be discussing my answers for pre-lab questions 1 through 5 and in lab 1 through 3. This is my solution for question 1. So what I did is I split that up into output 1 and this part up into output 2. And I have those right here with those respective outputs. Then the final outputs right here. And I even have the S inverted right there. So this is question 2, and this is the NOT gate. You can see the one over here when the input is 0 volts, the output is 5 volts. And this one, when the input is 5 volts, the output is really close to 0 here. So, it's basically from 1 to 0. Moving on, this is the AND gate for question 2. An AND gate, the output is high only when both inputs are high. So that you can see that here both inputs are high and the output is high, but for all the other ones they're really close to 0. That means it's off. Moving on, this is the OR gate, and an OR gate is high only if either output or either input is high. So you see that one these are high, so the output's high. None of these are high, so the output is low. And if I scroll down, you can see that one output or one input is high, so the output is high. And then the one input is high, so the output is high. So this is question 3, and these are the 4 cases when S is equal to 0 or low, and it shows all the outputs right there. So you have all these 4 cases, and those represent true to this truth table down here. So these are the 4 cases where S is equal to 1 or high, and when you match these cases with the truth table, these are true. Like, it matches these values down here to the truth table. So this is question 4, and I outlined 2 cases here where S is equal to 0 and A and B are 1 and the LED is on. Then you can see it's on. And this one where S is equal to 0, A is 1 and B is 0 and the LED is on and it's on. Here are 2 more cases for the question 4, and these ones the LED is off, and you can see that it's off, and you can see that it's off in this case too. In the interest of time, I can't show these other cases, but I went through and checked that they were true, so I just listed them right here. And these also represent the truth table. So this is question 5, and I have the 2 muxes right here, the 2 outputs right here, the final output and the final LED. So this is question 1, and I have my 3 chips. That first one is the AND chip, the 08. The next one is the OR chip, the 321. The last chip is the 04 inverter. And I have my 330 ohm resistor, orange, orange, brown. These logic gates are placed right because the notches are facing the left side, meaning those are where the pin 1s are. This is my circuit for question 2 in lab. So this is for question 2, and this is the case where S equals 0, A equals 1, B equals 1, and the output is 1. And you see it's the LED lit up. So this is for question 2, and this is for the second thing I'm trying, where S equals 0, A is equal to 0, and B is equal to 0. And the output is 0. That means the LED is off, and it is off. So I showed you the 2 cases. I went ahead and tried the 6 other cases by manually moving the wires, and they matched the truth table. I did that to save time for the video. So this is question 3, and you see that A is in the pin 4 and B is in pin 8. And right now S is in the power line, and the LED is flashing every 2 seconds, responding to the frequency of input B. And when I change this from power to ground, you see that it starts flashing. So you see that it starts flashing at the input frequency of 10 because it's back, because S is in ground, responding to the frequency of A.